fellow viewers. You're welcome once again to Simplified Maths class. Thank you very much for subscribing to our videos, and if you have not subscribed, please do subscribe to the video. Alright, today we'll be looking into the topic Venn diagrams, the use of Venn diagrams in solving set-related problems. Venn diagrams. We'll go straight to the point without waste of time. For instance, we're given a group of students were asked what their favorite colors were. 40 said they love red and 65 said they love black. Now, if 10 of the students love both colors and 45 love neither of the above two colors, how many of the students were surveyed? How many of the students love black but not red? And how many of the students love red only? So we are going straight to point. The first thing we need to do is to represent this information in a Venn diagram. Then from there we can find what they want us to find. Alright, so solution. So this is a Venn diagram. So it involves two scenarios. Alright, so we have red and black. And then we have the universal set. Now they say the group of students were asked what their favorite colors were, which means we don't know the number of students that were surveyed. We don't know what the entire set is, the universal set, which is the number of students that were interviewed. We don't know the number. It's what they want us to find. And then they say 40 said they love red. Red. 40 love red. And then 65 said they love black. So black, that's 65. And then 10 of the students love both colors. So we have 10 here. 10 love both colors. 45 love neither of the above two colors. So we have 45. They are in the universal set. They were surveyed. But they do not love red. They do not love black. They are outside red and black. So neither of the two colors, we have 45. So the first question they say we should find is how many of them were surveyed. Please take note. If you are to find the number of the universal sets, alright, the number of the universal sets, the cardinality of the universal set, that's the number of the universal set, it will be equals to the number of those that love red plus the number of those that love black minus the number of those that love red and black, then plus the number of those that do not love red and black. They don't. Alright, so the number of the universal set, the cardinality of the universal set, will be equal to the number of all those that love red plus the number of all those that love black minus the number of those that love red and black, that's red intersection black, and then the number of those that do not love red and black. That's how you have number of red union black or complement. The number of red union black or complement, meaning that they do not love red and black, so they are outside. Alright, so we are going to have that to be equal to number of the universal set. It wasn't given, it's what we are looking for. Number of the universal set will be equal to the number of those that love red, 40, plus the number of those that love black, 65, minus the number of the intersecting, those that love red and black, 10, plus the number of those that do not love any of the two colors, which is 45. Please, this is the general formula we use when you are trying to solve problems that involves Venn diagram, two scenarios, two cases. Venn diagrams with two unknown. Alright, so we are going to have that to be the number of the universal set will be equals to 40 plus 65, that's 105. 105 minus 10 plus 45. So this plus this is 105 minus 10 plus 45. 105 minus 10 plus 45. So we have 140. Therefore, the number of the universal set will be equals to 140. It therefore means that we've been able to find the I part. 140 students were surveyed. 140 students were surveyed. So we've been able to answer the first one. How many of the students were surveyed? They are 140 in number, represented by the universal set. That's 140. But I want you to understand something. Now, when they say 40 love red, now understand that out of these 40, there are 10 of them who are lovers of black as well. Take note, that's the 10 intersecting. It means out of the entire of this red is 40. So 10 love red and black. So 40 actually love red. It therefore means that those that love red only will be 40 minus 10. That will be 30. And those that love black only, take note, out of the whole of the people who love black, 65. 10 of them also love red. So it means for you to have black only, you subtract 10 from the 65. So that takes us to the I, and I. All right, we're going to find out those that love black but do not love red. I. So the number of those that love black but not red. The number of those that love black but not red, all right, will be equals to how many love black? That's 65. Minus how many love black but also love red? 10. So you take away the 10. It means those that love black but not red will be 55 in number. And then the last one, we said how many love red only? The number that love red only. How many love red only? Those that love red were 40. Minus the 10 that love both red and black. So we take out that 10. It therefore means that those that love red only will be 30 in number. 30 students, all right? Please take note of that. 55 students. All right, 140 students. So that's how we solve problems that involve Venn diagrams. When the Venn diagrams has to do with two-dimensional. So let's try another one before we take three-dimensional problem for Venn diagram. Let's go straight to the point without waste of time. All right, a question might be given. Maybe probably they say that in a class of 50 students. In a class of 50 students. Okay, let me write it out too. In a class of 50 students. In a class of 50 students, maybe 35 love, or maybe 35 offer accounting, and then maybe 28 offer biology. 35 offer accounts, while 28 offer biology. All right. Then you might be told that maybe probably 5 of them offer maybe neither of the two. Maybe 5 offer neither of the two. Maybe 5 students offer neither accounts nor biology. Now the question will be, how many of the students, how many offer both courses, that's account and biology, and then how many offer, let's say purely accounts. Okay, solution. So we are going to represent that in a Venn diagram again. So we take this as a Venn diagram, two-dimensional. All right, so we have, they said in a class, the universal set is 50. In a class of 50 students, so the universal set is 50. We're told that 35 offer accounts, so this should be accounts. We have 35. And then they say 28 offer biology, this is biology, so we have 28. Take note of that. And then they now said how many offer both courses. So we are looking for those that offer both accounts and biology. We are looking for X. We want to know those that offer both accounts and biology. And then they have also told us that 5 students offer neither accounts nor biology. That means there are 5 students in the class who do not offer accounts or biology, but they are in the class. So there are 5 of them. So we want to know first and foremost how many offer both courses. Don't forget the formula is still the same. The number of the universal set will be equals to the number of A plus the number of B minus the number where A intersects B, and then plus the number where A union B or complement. That's neither. The formula is still the same. So we have number of the universal set. They say it's 50. Is equals to the number of those that offer that count is 35 plus number of those that offer biology, that's 28, minus number of those that offer accounts and biology, that is X. That's what we are looking for. Then plus the number of those that do not offer accounts or biology. That's why we say account, biology or complement. They don't offer accounts or biology. And that's 5. All right. So we are going to have 50 is equal to 35 plus 28. 35 plus 20 is what? 63. 63. 35 plus 28 is 63. Let's add 5 plus 5. So we have 68. 68 minus X. So 35 plus 28 plus 5 will give us 68. Then minus X. Alright, so this, let's make X the subject of formula. So a negative X will cross to become a positive X. Take note of that. So we still have 68 here. Whereas this 50 is positive, crossing will become negative 50. So we have collected like terms. A negative X crosses to become positive X. 68 is still the other way, and so 50 crosses to be a negative 50. Therefore, X will be equals to 68 minus 50. So that gives us 18. It therefore means that 18 offer both courses. 18 offer both courses. Now, how do you know if 18 actually offer both courses? How do you know? You can bring up what we call the adjusted Venn diagrams. So you have to bring out the adjusted Venn diagrams. Adjusted Venn diagrams that will show you. Alright, so let's bring out the adjusted Venn diagram. This is adjusted. So we have this, This is our A, our B, the universal set, which we said is 50. Alright, so we have 5 here. Now let's begin. We've been able to find the value of X. We've been able to find the value of X, which is 18. So that means 18 offer both account and biology. Now they say 35 offer account. But out of that 35 that offer account, note that 18 also attend biology class. So for us to know those that purely attend accounts without venturing into the biology class, you will take the 35 and subtract 18. So 35 that was given there minus 18 will give you the purely account, and that will be 17. And then we also have 28 that offer biology. But out of that 28 that offer biology, 18 also attend accounts class. So for you to have purely biology, it will be 28, which was originally here, minus 18. And that gives you 10. Alright, now how do you know you're correct? It means if you actually add this 17 plus 18 plus 10 plus 5, you will have the number of students in that class, which is 50. Let's see. So 17 plus 18 plus 10 plus 5. That gives us exactly 50, which is the number of students in that class. So this is the adjusted Venn diagrams to know if your data is actually correct. Now that was iPad. They said we needed to know how many offer both courses, and we've gotten the 18. Now it will be easy to answer the the second part of the question. So the second part of the question, said how many number of students that offer purely accounts or accounts only. Purely accounts or accounts only. So that will be what? Purely account will be 35 minus 18. So that will be 35 minus X. And we have computed the X to be 18. So 35 minus 18. And that gives us 17, which is what we have here as purely accounts. So that's how we solve problems that involve Venn diagrams, 2-dimensional. So we'll go straight to 3-dimensional problem that has 3 circles. All right. So let's take that.